Now we shall see about unit step response. So, as we already know that impulse response, what is an impulse response? So, when the input is impulse signal, the output that comes from the system is said to be impulse response. In the similar way, when we give a unit step signal as the input, let us consider this is an LTI system. This is an LTI system. When we give unit step signal as the input, and you are going to get some output which is denoted as S of t. So, this S of t is called as a step response, unit step response. Okay, and you already familiar with the unit the convolution. The output is nothing but the convolution of the input and the impulse response, as y of t is equals to the input convolved with the impulse response. So, similar way, here the input is u of t. So, u of t convolved with the impulse response h of t, and or else we can also write this y of t is equals to h of t convolved with u of t. So, that is equals to integral minus infinite to infinite h of tau u of t minus tau d tau. We can write like this, integral minus infinite to infinite h of tau u of t minus tau d tau. So, this is from the impulse convolution integral that we already discussed in the class. Okay. And you already know that u of t minus tau u is equals to 1 when t minus tau is greater than or equals to 0, and that is equals to 0 when t minus tau less than 0. So, or else we can also write this as 1 for t greater than or equals to tau or tau less than or equals to t. Okay, is equals to 0 t less than tau, t less than tau or tau greater than t, tau greater than t. Okay, that means we can say that we can modify the above equation, that is y of t is equals to integral minus infinite to infinite h of tau u of t minus tau by using this relation. So, y of t is equals to integral up to t only, it is equals to 1. So, that means the upper limit goes to t instead of plus infinity. So, minus infinite to t h of tau into 1 d tau. So, that is equals to integral minus infinite to t h of tau d tau. So, that is the relationship. So, that means y of t here now it is s of t, so that is output. So, why? Because we have considered our the step response as s of t rather than y of t. So, s of t is equals to integral minus infinite to t h of tau d tau, or we can also write this relationship by taking the differentiation on both sides with respect to t. So, we can also write this as ds of t by dt is equals to h of t. So, that this relation is also a valid relation.